Today I want to talk about the Private Packages Repositories feature in Chainguard images. Private Package Repositories gives you access to the APK packages that make up your Chainguard images. So instead of only being able to use Chainguard images as they come, you can build your own custom images with a tailored set of packages for your own use case. And as long as you only use packages from your Private Package Repository, you will still be covered by the remediation SLA. So what does this look like and how can you use it? Let's jump straight to a demo. Before we get started, I do need to mention that as of the time I'm making this video, Private Package Repositories are not enabled by default. So you may need to talk to your account team to get access. In order to access your private repo, you're going to need to have an access token. And to get that, you'll need to have chainctl installed, and then you can do chainctl auth token. We don't want the default token though. We want one with the audience set to Chainguard's APK repository, which is apk.cgr.dev. Now, this is a secret that you do need to take care of, but by default, it has a TTL or time to live of 1 hour, after which it can't be used. Because of that, I'm not worried about showing tokens in this video because they will have long since expired by the time you see it. So how can you use this token? Well, let's start a container with APK tools and point it at the repository. Now, we're passing in the token via this HTTP auth environment variable. That's how APK tools authenticates the private repositories. Do be a bit careful if you do this yourself about using environment variables for secrets. In general, it's not a great idea as they can easily leak. In this case, we're just doing a demo, so I'm not too worried. The other thing to be aware of is that I'm using the Chainguard base image from the Chainguard.edu repository. So I have access to the Chainguard.edu organization and I'm using this image. In your case, you may not have access to this image. You can, of course, use any development image. You do want one with APK tools and ideally a shell available. So probably a -dev image. The first thing we need to do now that we're in a container is add our repository to the Etsy APK Repositories file. So at the minute, it has the Wolfie repositories in it, and we're going to add our organizations repository in here. As I said a minute ago, I have access to the Chainguard.edu organization, so that's what I'm using. You'll put your own organization name here. If you're not sure what it is, you can log into the console and there's a full description there. I now have all three repos here, so Wolfie and our private package repository. But there is something to be aware of. If you keep the Wolfie repository here, you're able to install Wolfie packages. But if you install a Wolfie package, it's not going to be covered by the CVE remediation SLA. For that reason, I'd actually recommend overwriting this file so that we only have this line. And you can only install from your private package repository. So you're sure that everything's covered under your remediation SLA. We've changed it now so that you only have access to the Chainguard.edu repository here. We can cat that just to be sure. Yeah, so only our private package repository is available under Etsy APK repositories. If we do an APK update, everything's okay, and we can list what packages are available to us. So this is all the packages that are available in that private package repository. You can, of course, also search. When you find we've got curl available, you can add packages as normal. This also is APK policy command. So if you do have more than one repository active, you can type APK policy to figure out which one you're using. So here I can see that curl was installed from the Chainguard.edu repository. Okay, so let's move on to see how you'd actually use this and take a look at a Docker file. So this Docker file uses our private package repository to add an extra package into an image. In this case, we're using the Python-dev image, so we do have APK tools and a shell available. The first thing we do is overwrite the Etsy APK repositories file so that only the private repo is available. That way we're sure that we're not going to accidentally add a package that isn't covered by the remediation SLA. We then use this Docker syntax to pass the token in as a secret. So when we run the Docker build on this, we'll have to pass it the token, and it's going to make it available at this /run/secrets cgr-token file. And then we're going to cat that and make it available in this HTTP auth environment variable so that APK can use it. And finally, we can then run APK update and APK add our curl package. We can then create an entry point script that depends on the curl package. In this case, we're just doing a simple curl, perhaps to check network connectivity before we start our application. In this case, I'm just running a simple web server. So let's jump out and see how we build that image. So we can build the image like this. We're first creating the CGR token environment variable, which includes the chainctl auth token. That gets passed into the Docker build here, and then Docker will take care of saving it to the cgr-token file under run secrets, I believe it was. We tagged it as Python app, and that's about it. It's cached, so that was pretty quick. Let's run it. So the first thing you see is the curl output, because I didn't suppress that. And then our starting application and our Python web server has started up. So that's how you can use private package repositories in a Docker file. But there's still a problem, because now instead of a minimal image, we have an image with a shell, APK tools, and potentially other build tooling inside it. If you wanted to create a truly minimal image, you can use Chainguard's AppCode tool. And basically what AppCode does is you give it a list of APKs and it creates an image from those without any extraneous tooling. So I have an example here. And what this will do is it will use our private chainguard.edu repository, and it will build an image with a Python 3.13 package, the curl package, and the UV package. Can install AppCode locally, but I'm just going to call it from a Docker image. Now, AppCode supports the same HTTP auth environment variable as APK, so we see that being passed in here. We do mount the current directory as /work, so that's how it gets input files and gives us output files. Then we're calling build. We're giving it the ppr.appco input file. We're saying we want to build an image called mypython. I'm asking it to output to a file called mypython.tar. Okay, let's try it. And you can see it's installing the APKs plus all the dependencies. And we can see it's built this mypython.tar, and it's also given us a couple of SBOM files. We can load this into Docker. Now, I haven't bothered setting an entry point or anything, so normally you'd set a lot more metadata, but I just wanted a minimal example. So if I do docker run -- entry point, this I expect to fail because there is no shell. Right, so there's no shell in there, there's no Git, there's no GCC, etc. But there is curl, there is Python, and there is UV. That's pretty cool, and you can see how it could be a useful base image for moving Python applications into using a multi-stage Docker file build. And another interesting thing is if we compare to the other Python images, so we can see here the latest dev version in the Chainguard.edu repository for Python is 927 megabytes, compared to the latest version with just Python, which is only 87 megabytes. So there's a big difference between these two images. And it's because the dev version includes things like pip, UV, GCC, a shell, APK tools, etc. So there's a lot of scope to create a more minimal base image here. And that's what we kind of did by adding Python and UV. So you've not just got Python in the image you built, you've also got the UV package manager, but you don't have everything else that you may not need. And if we take a look at our Python image, so we have Python and UV, but we don't have everything else in that image, and hence it's only 158 megabytes instead of 927 megabytes, which is a massive saving. That's all I wanted to show in this video, but hopefully you get the idea of how you can use private package repositories to create custom images that are tailored to your use case without compromising on minimalism or losing the remediation SLA. As ever, let me know if you have any questions.